नेक्स्ट अपन को क्या बनना है? चलो, तो लेट्स स्टार्ट विथ सिस्टम ऑफ पार्टिकल्स. So what is system of particles? Till now, what was happening was, till work, energy and power, what we were observing was there was one object and which we were considering it to be a particle, right? Even the truck was considered a particle, right? But here what is happening is there are many particles which are involved here, right? Even a rigid body has many particles. This is what we will be considering. ठीक है? Now, first is, there are two types of system of particles. One is discrete particle system, and the other one is continuous bodies. Okay. Now, what is this discrete particle system? Pay attention. Suppose I have 100 kg mass with us. ठीक है? We have 100 kg mass with us. Okay. So now this 100 kg mass is divided or is distributed at these 4 points. Let's say this is 50 kg, this is 10 kg, and this is 40 kg. So this is discrete distribution of mass. Masses are located at a certain point. Beyond that, there is no mass. Again, you will find some mass after moving some distance. And then again, there will be a point where the mass is concentrated. Beyond that, there will not be any mass. Again, at some point, you will find that 40 kg and beyond that, you will not find any mass. Got it? The points, the masses are located at certain points. Yes or no? Understood?
Yes, sir.
So this is called as discrete distribution of mass. Now, what about continuous bodies? Suppose I take a block of 100 mass, 100 kg. At every point on this block, there is some mass. Clear? Hello?
Yes, sir.
So this is continuous distribution of mass along the length or along the volume, you can say, right? Because we are taking a cuboidal block here. So this is how we identify what are discrete particle systems and what is a continuous bodies. Any doubts in this? Please say, please ask.
No.
Okay. Now comes center of mass. So what is center of mass? It's a point where the entire mass of the system of particles is assumed to be concentrated. Center of mass is a point where the entire mass of system of particles is assumed to be concentrated. Understood, all of you? Hello?
Yes, sir.
Yes, sir.
Now, what about center of mass of a discrete particle system? See, there are multiple particles, right? Multiple bodies here. So, how to give center of mass of a discrete particle system? Check. देखो ध्यान से. Suppose we have this XY plane. Right? And we have these different bodies here. Let's say these are 3 different bodies which are here. And this is the origin, right? This is origin. This object has mass m1, this object has mass m2, this object has mass m3. Now, this is position vector of center of mass of object 1 with respect to origin. This is position vector of center of mass of object 2 with respect to origin. And this is position vector of center of mass of object 3 with respect to origin. All of you understood this? Yes or no?
Yes, sir.
Yes, sir.
Pakka? Theek? So we have the position vector of center of mass of these three particles with respect to origin is given as m1 r1o plus m2 r2o plus its m3 r3o divided by its m1 plus m2 plus m3. It's m1 plus m2 plus m3, right? Or we can also write it as summation of mi-rio divided by summation of mi from I is equal to 1 to 3, and here it is I is equal to 1 to 3. If there are n particles in the system, then we write it from I is equal to n. All of you understood this? Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Now, for a two particle system, let's see what happens when there is only two particle system. We discussed this case for two particle, okay? One second, I'll just move this to this place. Okay. So, two particle system. This is an example or an application, whatever you want, you can say. Okay? So, for a two particle system, the center of mass of a two particle system divides the line joining the masses in the inverse ratio of the masses. Okay? Now pay attention. First of all, we have these two particles here. This is particle 1 and this is particle 2. Clear? Let's say the values are, this is mass m1, this is mass m2, and the distance between them is r. Or let's write it as d. The distance between them is d. Clear? So center of mass of this two particle system will lie between the two particles, and it will be on the line joining the two particles. All of you are clear with this? Yes or no? Hello?
Yes, sir.
Any doubts in this? Anybody is having any doubts? Now, if this distance is r1 and this distance is r2. Now pay attention. R1 upon R2 is as good as M2 upon M1. Clear hai sabko ye? The center of mass of a two particle system divides the line joining the masses in the inverse ratio of the masses. So R1 upon R2 is inverse ratio kya hoga? It's M2 upon M1. Clear hai all of you?
Yes, sir.
Yes, sir. Yes, sir.
Also R1 plus R2 is equal to D. R1 plus R2 is equal to D, right? Now, when you actually solve it for R1 and R2, what happens? When you solve it for R1 and R2, what happens? See, R1 will be M2D upon M1 plus M2, and R2 will be M1D upon M1 plus M2. आप लोग को ये सॉल्व कर पाएंगे आप लोग, या मैं करके दिखाऊं आपको? कौन से इक्वेशंस? यू नीड टू सॉल्व दीज टू इक्वेशंस. this one, and this one. Understood, all of you? Hello.
Yes, sir.
Copy it. Once you are done, just type done in the comment window. All of you done? अक्षित हो गया बेटा?
सर 1 मिनट लास्ट.
ठीक है. लिखो डन है ना वहां पर? चलो ठीक है. अच्छा, ये डिराइव कैसे हुआ पता है किसी को? सी हाउ इट इज डिराइव्ड. So these are two different objects. Okay. And this is the point. Okay, center of mass, C. Suppose it is at a zero, it is at the zero position, right? This is the zero position. This distance is how much? This is say R1 and this is say R2. We are not aware of what is the values are R1 and R2, but we are definitely aware that R1 plus R2 is D. This is M1 and this is M2. Now, center of mass is at origin. Yes or no? You have this expression RCM with respect to ground, right? Or with respect to O is equal to M1 R1 with respect to O. This is origin, right? Plus M2 R2 with respect to O upon M1 plus M2. All of you. You are aware of this? Yes or no? Say yes or no.
Yes, sir.
So this value is 0 or not? Because it is at 0 only. What is this? This is M1 R1 minus I cap. Plus this is M2 R2 plus I cap. Divided by M1 plus M2. Clear है सबको ये? हेलो हेलो हेलो.
हाँ सर.
Yes, sir.
तो जब इसको सॉल्व करोगे तो तुम्हें देखो क्या मिल रहा है. R1 अपॉन R2 इज इक्वल टू M2 अपॉन M1. मेरे ख्याल से ये दिस इज हाउ इट इज टू बी डिराइव. All of you can write this expression. You can write this derivation and an exercise, right? करो जल्दी से. Done. हुआ नहीं हुआ बेटा? आरना आ रहा है समझ में?
Yes, sir.
ठीक है. रोनन, अक्षित,
हाँ सर.
ठीक है. चलो. Now let's discuss motion of center of mass. Right. All of you are aware that if mass of the system of particles is constant, then external force is equal to mass into acceleration of center of mass, right? So if there is no external force, if F external is equal to 0, right? What will happen to the acceleration of center of mass? It becomes 0. Yes or no?
Yes, sir.
If F external is equal to 0, then acceleration of center of mass is 0. ठीक है. तो if initially the center of mass was at rest, it will remain at rest. Or if it was moving with uniform velocity, it remains moving with uniform velocity. Yes or no? All of you.
Yes, sir.
Sure? Everyone.
Yes.
ठीक है. So now what happens here is, check करो इधर, ध्यान से देखना, ठीक है? Suppose we take these two objects. Okay? The distance between them is say 40 meters. But let's write it as D only, na? Why to be bothered by that? So the distance between them is D. This is mass M1, this is mass M2, and this is the center of mass C. ठीक? अब देखो बच्चों, this length is R1, this length is R2. Clear? Hello? अरे हाँ ना बोलो ना बे.
Yes, sir.
Now, center of mass is given as what? Position of center of mass is given with respect to ground. Let's say we are observing it from ground only, right? Is given as M1 R1G plus M2 R2G divided by M1 plus M2. Clear है ये सबको? Hello, hello, hello.
Yes, sir.
Okay. Now, these objects, they start moving towards each other because of their mutual attractive force or gravitational attraction force, right? Gravitational force will attract both of them towards each other, right? So they start moving towards each other. And after a certain time, mass M1 has moved a distance, say, its position has changed by some delta R1. This is the change in the position of R1, right? Similarly, there will be a change in position of M2 also. Yes or no? Hello.
Yes.
Okay. Right. Now, we need to find the relation between this delta R1 and delta R2. Pay attention here. Is there any external force acting on this? Is there any external force acting on this two particle system? Any external force?
No, sir.
All of
Gra-
you.
No.
Ronan, Akshit, Arna,
No, sir.
Niharika. नहीं है ना?
No, sir.
There is no such force, right? There is no external force here. So since there is no external force, so center of mass, which was initially at rest, will remain at rest. Yes or no? This center of mass, which was initially at rest, remains at rest. Yes or no? Hello?
Yes.
Yes.
So is there any change in position of center of mass? RCM में कोई change है? No.
No, sir.
Zero हो गया ये. This change is because of change in position of 1 with respect to ground plus change in position of 2 with respect to ground, right? Divided by M1 plus M2. So from here we get, pay attention all of you. It's M1 delta R1G plus M2 delta R2G is equal to 0. Or you can write it as, if it was delta R2G is simply minus M2 upon M1 into delta R1G. So if you take modulus sign and if you remove the vectors, you simply get R2 upon R1 is equal to M2 upon M1. So if R1 upon R2 was M2 by M1, the same will be delta R1 by delta R2. It's the same ratio. It doesn't change. Got it, all of you? Yes or no?
Yes.
लिखो लिखो Done? Now solve this question for, first of all, the distance D is 40 meters. Mass M1 is 9 kgs, or mass M1 is 3 kgs, and mass M2 is 9 kgs. Find the location of center of mass from M1. Find the location of center of mass from N1. Clear है सबको? Hello? Clear or not? Say yes or no.
Yes.
अबे आवाज आ रही नहीं आ रही मेरी?
Yes, sir.
हाँ. Now, if change in position of R1 is, if change in position of M1 is say 10 meters or 12 meters, what is the change in position of R2? निकालो जरा जल्दी से देखें क्या करते हो तुम लोग. Done, all of you? Type your answers. चलो. So first of all, what is the position of center of mass? R1 की value क्या होगी बेटा? C 1:3 है. It's M1 upon M2 is what? It's 1 upon 3, right? So you have to divide R1 plus R2, that is D, in 4 parts. One part of D is how much? One part of D is how much? If you divide it equally into 4 parts, one part of D is how much? 10 meters, right? So this is R2 upon R1. So this comes out to be 30 upon 10. Clear है सबको? नहीं नहीं ये गलत है.
Yes, sir.
R1 upon R2 is R2 upon R1 हुआ ना? क्या किया मैंने ये? This is 1:3. So R2 upon R1. So R2 is R1 by 3. हाँ ठीक तो है. तो this is 10 meters and this is 30 meters. Understood all of you? Hello.
Yes, sir.
Now,
Yes.
what about the change? Delta R1 was what? 12 meters, right? So this should be what? 1:3 चाहिए ना? So this should be equal to 4 meters. Ratio of delta R1 by delta R2 is same as ratio of R1 to R2. So once you have delta R1 as 12, you get delta R2 as 4 meters. Understood all of you? Hello.
Yes, sir.
Okay. Now comes velocity and acceleration of center of mass. Pay attention, huh? Velocity and acceleration of center of mass. See, velocity of center of mass with respect to a common point G is given as sigma of mi vig from I is equal to 1 to n divided by sigma mi from I is equal to 1 to n. निहारिका जी आपको समझ आ रहा है कि नहीं आ रहा है?
Yes, sir, आ रहा है.
And what about acceleration? Acceleration of center of mass with respect to ground is sigma mi aig from I is equal to 1 to n, right? Divided by sigma of mi from I is equal to 1 to n. Clear है सबको? All of you, hello, hello, hello.
Yes,
Yes.
sir.
ठीक है, लिखो. All of you done? Hello.
Yes, sir.
Okay.
No, sir, wait. Yes, sir.
देखो इधर. This is a plank. The length of the plank is L. And mass of the plank is M. ठीक है? All of you, pay attention. The center of mass of the plank is situated at its center, right? This is the center of mass of the plank. So let it be a very small dot here. So this is the center of mass of the plank. A man is standing on this plank. A man is standing on this plank at end A. The mass of man is m. And this is the location of its center of mass. This was the location of center of mass of plank. Right? All of you understood this or not? Till this point, any problem, any challenge? Hello?
No, sir.
Now, this is the center of mass. This is the center of mass of these two objects taken together as a system. Right? Draw a line here. Okay? This is the center of mass of this. Ronan, you understood or not?
Yes, sir.
This is the center of mass of this two particle system, which is one of them is Planck, the other one is man. So we are considering man plus Planck together in the system. Clear? Now, what happens here is the man starts moving towards end B of the plank. Right? So friction will act in the forward direction on this man. Yes or no? Whenever you walk on the ground, friction acts in the forward direction. Yes or no? All of you.
Yes, sir.
Say yes or no. Please be quick, huh? And friction will act in the backward direction on the plank. Now, my question to all of you is there any external force acting on this two body system? There is no friction between the plank and the ground. Here there is no friction, right?
No, sir.
There is no external force acting on this two particle system. All of you clear with it? Arna,
Yes, sir.
Beswar, Niharika,
Yes, sir.
Ronan, Akshit, Adesh, Kshitij,
Yes, sir.
right?
Yes.
Now, what happens here is, see, so what will happen? A will move in the forward direction. Sorry, the man will move in the forward direction, but the plank will move in the backward direction. ठीक?
Yes, sir.
The man is moving from end A to end B. ठीक है? तो अब ये पहुंच गया यहां. ठीक? किसी को डाउट है क्या? And center of mass will not go anywhere because there is no external force acting on the center of mass. So it remains as it is, right? All of you understood this? Yes or no?
Yes, sir.
बोलो बे
Yes,
हाँ
sir.
या ना. समझ आ रहा है
Yes,
नहीं आ
sir.
रहा है? हाँ. अब देखो क्या पूछता है ये. Find the displacement of plank with respect to ground. ये पूछता है वो. तो इसका मतलब क्या हुआ? कितना डिस्प्लेसमेंट हुआ? ये जो डिस्टेंस देख रहे हो ना तुम, this is the displacement of plank with respect to ground. Got it, all of you? Even you can say this distance is displacement of man with displacement of plank with respect to ground. Center of mass कितना आगे बढ़ा plank का, वो भी तो हो सकता है ना? हेलो,
Yes, sir.
Yes, sir.
ये सेम लेंथ होगा, है ना? तो अब हमको ये निकालना है. कैसे करेंगे देखो ध्यान से. All of you pay attention. We have RCMG is equal to what? Its mass of man, position of man with respect to ground, plus mass of plank, position of plank with respect to ground, center of mass की position की बात कर रहा हूं. ठीक है बेटा, यहां पर divided by, we have this m plus capital M, right? Now, when you write delta here, change in position of center of mass of the system with respect to ground, you simply write delta here also, delta RMG plus capital M into delta RPG divided by M plus capital M. Yes or no, all of you? Hello, hello, hello.
Yes, sir.
But this is equal to 0, right? So we have now one equation which is delta M delta RMG plus capital M delta RPG, and this is equal to 0. आरना आपको समझ आ रहा है बेटा?
Yes.
नहीं आए तो पूछना, ठीक है? अब देखो इसमें क्या करोगे, ये तो एक इक्वेशन हो गई. There is one more equation here. What is that? Change in position of man with respect to Planck is given to you. See, what is it? It's delta RMG minus delta RPG. All of you are aware about relative motion. So this is L I cap. Yes or no? Say yes or no.
Yes, sir.
Yes, sir.
Because this man is moving in this forward direction and this is Li cap, right? This is displacement of man with respect to a man on the plank. Now, can you solve these two equations? All of you, can you solve these two equations? This one and this one to get the value of delta RPG and delta RMG. कर सकते हैं कि नहीं कर सकते हैं? Hello. So when you solve it, delta RPG is what? It's minus small m Li cap upon m plus capital M. And what about delta RMG? It's capital M Li cap बच्चों समझ आया नहीं आया तुमको? हेलो.
सर वो
हाँ,
माइनस
सॉल्व करो ना उसको, दोनों साइन को सॉल्व करो, दोनों इक्वेशंस को जो ग्रीन से मार्क किया है मैंने. सॉल्व करोगे तो ये आएगा, ठीक है? करके देखना अभी क्लास के बाद. कॉपी इट ऑल ऑफ यू. जस्ट रीड इट वंस, इफ यू हैव एनी डाउट प्लीज आस्क, और फिर कॉपी करो इसको जल्दी से. चलो हो गया. Now homework for all of you is read the chapter, read this. Till this point, 9.1, okay?
Yes, sir.
उसके बाद क्या करना है सुनो ध्यान से. सॉल्व ऑब्जेक्टिव 1, ऑब्जेक्टिव 2, ऑब्जेक्टिव 5, ऑब्जेक्टिव 6. क्लियर? हेलो.
Yes.
ऑब्जेक्टिव नहीं रे, सॉल्व एग्जाम्पल था वो. कहा तुम लोग भी ऑब्जेक्टिव. नाउ आफ्टर दैट सॉल्व ऑब्जेक्टिव 1, ऑब्जेक्टिव 2, 3, 4, 5, 6, 7, 8, 9, 10. बस इतना करो पहले. फिर ऑब्जेक्टिव 2 में 1, 2, 3. इतना कर लो पहले. देन एक्सरसाइजेज में स्टार्ट फ्रॉम 1 एंड कंप्लीट टिल 10. यहाँ 10, ठीक है. फिर 12, 13, 14. बस. लीव this 11th one. So from 1 to 14 is what you have to do, all of you. Exercises में लिख
Yes,
लो.
sir.
और अभी से खत्म करना शुरू करो. इसका बैकलॉग बहुत खतरनाक होता है. फिर 3 महीने खत्म नहीं होगा इसका बैकलॉग, क्योंकि इसके बाद अगला चैप्टर भी बड़ा है ना. तो अभी कब है तुम्हारी क्लास? अगली कब होती है? ट्यूसडे, थर्सडे,
ट्यूसडे.
ट्यूसडे 10 to 11. कोई भी अभी कम से कम इसका 80% होमवर्क होना चाहिए तुम्हारा. और ये मैं तुमसे कह रहा हूं 10 तारीख तक, 10 सितंबर तक एकदम डिलीजेंट हो जाओ, तो तुम्हारा ये चैप्टर खत्म हो जाएगा ठीक से. ये 2 चैप्टर्स, ये दिस इज द अपहिल टास्क. एंड इफ यू मैनेज दीज टू, बिलीव मी, थिंग्स विल बी इजियर फॉर यू, मच इजियर फॉर ऑल ऑफ यू. एंड इफ यू डोंट पे अटेंशन टू दीज 2 चैप्टर्स, पूरी फिजिक्स तुमको हमेशा भारी लगती रहेगी. अंडरस्टूड? आई एम क्लियर? जाओ मजे करो,
सर,
होमवर्क करो, होमवर्क.
एक्सक्यूज मी सर.
Bye, sir.
बोलो बोलो.
सर, वर्कड आउट एग्जांपल्स में आपने 2 और 4 बोला था.
क्या पता क्या बोला था मैंने? बताओ भाई, 2 और 4 बोला कि नहीं बोला मैंने वर्कड आउट एग्जाम्पल में?
सर 2 बोला था, 4 नहीं बोला था.
2 बोला था, 4 नहीं बोला था. ठीक है, चलो बाय.